This is a tutorial for your last assignment. I have chosen 2,4-dimethyl-3-hexene. You have to give the stick model, so the numbering goes from the closest branch, or 1, 2, 3, 4, 5, 6. So I have a methyl on the second carbon, I have a methyl on the fourth carbon, and the double bond is on 3. This structural model should spell out all the hydrogens and carbons. Pay attention to 4 bonds for each carbon. You shouldn't go wrong. Molecular formula for all of us is C8H16. Part 2, you have to do cis and trans version of the 2 isomers. Now cis happens to be the smallest elements in terms of atomic number on one side. So here I have hydrogen and CH3 on one side, and for the trans I have the H and CH3 across from each other. So this is a trans version, and then you have the cis version. Reactions, the first reaction is complete combustion, so I have to produce 8 CO2 and 8 H2O for my octene, and the amount of heat, because it's exothermic, and I have 12 oxygen. Incomplete combustion means I will produce carbon monoxide instead, and then it still gives me heat, and 8 H2O and number of oxygens are reduced. Hydrogenation will turn the alkene into alkane, so you're adding a hydrogen here, and here it gets saturated, and name of this is 2,4-dimethylhexane. Bromination, then you have to respect it again, 1 bromine here, 1 bromine here, and you go and spell it out. So this is 3,4-dibromo-5-methylhexane. Hydration is adding H2O. H2O, we decided we show it as HOH. So one of the hydrogen goes here, the OH goes here, but you can also have another isomer, so OH goes here, hydrogen goes here. And I'm giving you the 2 possible product or isomers, and I name them accordingly. Same rule applies when you add HBr or HCl, so you could have H here, Br here, or vice versa, and I have those. Finally, the 3D representation. This was my alkene. The double bond is right here. If you notice, there are 2 toothpicks here to resemble that. And then once I add bromines, I'm going to represent them as this white sort of stuff that I put here. Bromine comes here, bromine comes here, and the double bond became single bond. So this is 3D version of dibromoalkene, and this is the version of alkene to begin with. So good luck.